Welcome to ECHO 442, Study Session 6, Transportation Problem 2, Optimal Solution. Introduction. Like the simplex method of solving linear programming problem, solving transportation problem also involves iteration till you obtain the optimal solution. In this lecture, we will illustrate how you will work through a transportation problem and obtain the optimal solution. Objective. At the end of this lecture, you shall be able to work through a transportation problem and derive the optimal solution. Content. A. Steps in solving a transportation problem. Step 1. Set up the initial transportation table by using information contained in the problem. Step 2. Make initial feasible allocation. As stated in Lecture 5, there are different methods that you can use to obtain the initial feasible solution. The closeness of this initial solution to the final solution will determine the number of iterations that you will implement before you get to the final and optimal table. In this lecture, we shall discuss 3 methods of setting up the initial feasible solutions. These are Northwest Corner NWC rule, least cost method LCM, and the Vogel's approximation method VAM. Step 3. Calculate the total cost of the allocation. Step 4. Calculate the nominal, dispatch, and reception cost for each occupied cell by making the assumption that the transport cost per unit is capable of being split between dispatch and reception cost. You assign 0 value to the first dispatch cost. Step 5. Calculate the shadow cost of the unoccupied cells by using the value of the dispatch and reception cost estimated in Step 4. Step 6. Optimality check. Subtract the shadow cost from the actual cost to find out whether costs can be reduced by allocating into any of the unoccupied cells. Note that plus implies increase in cost, while minus implies cost reduction. Step 7. If it is not possible to improve the solution, you have obtained the optimum solution. If you can reduce cost by allocating to unoccupied cell, make maximum possible allocation into the cell where actual costs are less than shadow cost. Step 8. Repeat steps 3 to 6. B. Example: transportation problem workout. A firm of office equipment suppliers has 3 depots located in various towns. It receives order for a total of 15 special filling cabinets from 4 customers. In total, in the 3 depots, there are 15 of the correct filling cabinets available, and the management wish to minimize delivery costs by dispatching the filling cabinets from the appropriate depot for each customer. Details of the availabilities, requirements, and transport cost per filling cabinet are given in the following table. Available, required, customer A. 3 cabinets, customer B. 3 cabinets, customer C. 4 cabinets, customer D. 5 cabinets, total 15 cabinets. Depot X. 2 cabinets, N13, N11, N15, N20. Depot Y. 6 cabinets, N17, N14, N12, N13. Depot Z, 7 cabinets, N18, N18, N15, N12. Total 15 cabinets. Note: the body of the table contains the transportation cost per cabinet from the depot to the customer. For example, it costs 14 naira to send one cabinet from depot Y to customer B. You are required to determine the optimal allocation that will minimize the total transport cost. C. Solution step 1. Initial transportation table. As discussed in lecture 5, we first set up the problem in a standard transportation table and make initial feasible allocation. We will use the method of least cost to set up the initial feasible solution. D. Solution step 2. Initial feasible solution. First, allocation. You will see clearly that the cell with the least cost is cell X ratio B, with transportation cost per unit of 11 naira. The maximum possible allocation to this cell is 2. With this allocation, you will block cells X ratio A, X ratio C, and X ratio D. As they require no further allocation, since the available supply for row X has been satisfied. The transportation table after the first allocation is as follows. Second allocation. The next least cost is 12 naira in cells Y ratio D and Z ratio D, with the maximum possible allocation of 4 and 5 respectively. Since Z ratio D has the higher maximum possible allocation, the next allocation is to cell Z ratio D. This will enable us to block cell Y ratio D. The transportation table after the second allocation is as follows. Third allocation. Out of the remaining 9 unblocked cells, Y ratio C has the least cost of 12 naira with maximum possible allocation of 4. With this allocation, we block cell Z ratio C and the table becomes other allocations. Now we are left with 4 unblocked cells with the least cost of 14 naira in cell Y ratio B. The maximum possible allocation to this cell is 1. Because we have already allocated 2 to customer B from depot X of the total requirements of 3 by that customer. After this allocation, you will block cell Z ratio B and the next least cost cell becomes Y ratio A. The maximum possible allocation to Y ratio A is 1 because out of the total available cabinet of 6 in depot Y, we have already allocated 4 to customer C and 1 to customer B. After this allocation, you are left with only one cell, Z ratio A, with only one possible allocation of 2 to balance. The final table after all initial feasible allocations is as follows. E. Solution step 3. Total cost of the allocation. To calculate this, you will multiply each allocated unit by the relevant transportation cost and add up to get total as shown below. X. B ratio 2 cabinet at 11 naira per unit equals to 22 naira. Y to A. 1 cabinet at 17 naira per unit equals to 17 naira. Y to B. 1 cabinet at 14 naira per unit equals to 14 naira. Y to C. 4 cabinet at 12 naira per unit equals to 48 naira. Z to A, 2 cabinets at 18 naira per unit equals to 36 naira. Z to D, 5 cabinets at 12 naira per unit equals to 60 naira. Total cost equals to 22 naira plus 17 naira plus 14 naira plus 48 naira plus 36 naira plus 60 naira equals to 197 naira. Take 2 equals to 197 naira. F. Solution step 4. Dispatch and reception. Let D represent the dispatch cost from each depot and let R represent the reception cost per item at the customer's place. Thus, we assume that the transport cost per unit can be separated into dispatch and reception cost as follows. D bracket X plus R bracket B equals to 11 naira. 1. D bracket Y plus R bracket A equals to 17 naira. 2. D bracket Y plus R bracket B equals to 14 naira. 3. D bracket Y plus R bracket C equals to 12 naira. 4. D bracket Z plus R bracket A equals to 18 naira. 5. D bracket Z plus R bracket D equals to 12 naira. 6. To obtain the solution to these equations, let D bracket X equals to 0. With this assumption, equation 1 becomes 0 plus R bracket B equals to 11 naira, which implies that R bracket B equals to 11 naira. Substitute for R bracket B in equation 3 to get D bracket Y plus 11 naira equals to 14 naira, which implies that D bracket Y equals to 14 naira minus 11 naira equals to 3 naira. Substitute for D bracket Y in equations 2 and 4 to get R bracket A and R bracket C respectively. In equation 2, 3 naira plus R bracket A equals to 17 naira, which implies that R bracket A equals to 17 naira minus 3 naira equals to 14 naira. And in equation 4, 3 naira plus R bracket C equals to 12 naira, which implies that R bracket C equals to 12 naira minus 3 naira equals to 9 naira. Substitute the value of R bracket A obtained from equation 2 in equation 5 to solve for D bracket Z as follows. D bracket Z plus N, take 2. D bracket Z plus 14 naira equals to 18 naira, which implies that D bracket Z equals to 18 naira minus 14 naira equals to 4 naira. F. Solution step 5. Shadow cost of unoccupied cells. The unoccupied cells are X ratio C, X ratio D, Y ratio A, Y ratio D, Z ratio B, and Z ratio C. We can now calculate the shadow cost of each of them by using the dispatch and reception cost calculated before as follows. D bracket X plus R bracket A equals to 0 naira plus 14 naira equals to 14 naira. D bracket X plus R bracket C equals to 0 naira plus 9 naira equals to 9 naira. D bracket X plus R bracket D equals to 0 naira plus 8 naira equals to 8 naira. D bracket Y plus R bracket D equals to 3 naira plus 8 naira equals to 11 naira. D bracket Z plus R bracket B equals to 4 naira plus 11 naira equals to 15 naira. D bracket Z plus R bracket C equals to 4 naira plus 9 naira equals to 13 naira. G. Solution step 6. Optimality check. To check for optimality, you find the difference between the actual cost and shadow cost of each unoccupied cell. Unoccupied cells: X to A, X to C, X to D, Y to D, Z to B, Z to C. Actual cost: 13 naira, 15 naira, 20 naira, 13 naira, 18 naira, 15 naira. Minus, 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 minus. Shadow cost: 14 naira equals to minus 1, 9 naira equals to plus 6, 8 naira equals to plus 12, 11 naira equals to plus 2, 15 naira equals to plus 3, 13 naira equals to plus 4. The negative value for cell X ratio A means that total cost could be reduced by N1 for every unit that can be transferred into that cell. Therefore, the initial feasible allocation is not optimum. H. Solution step 7. Allocation to cell X ratio A. To do this, you will trace out a closed loop from cell X ratio A. You move clockwise to an occupied cell in the same row and draw an arrow. Then draw the arrow vertically and horizontally till you trace the loop back to the starting point in cell X ratio A. You then put plus and minus signs starting from a plus sign in cell X ratio A, followed by a minus sign, a plus sign and a minus sign. You identify the minimum value with negative sign and then add and subtract that value in each cell as the case may be. High. Solution step 8. Repeating steps 3 to 6. 1. Repeating step 3. Total cost of the allocation. X to A. 1 cabinet at 13 naira per unit equals to 13 naira. X to B. 1 cabinet at 11 naira per unit equals to 11. Y to B. 2 cabinets at 14 naira per unit equals to 28 naira. Y to C. 4 cabinets at 12 naira per unit equals to 48 naira. Z to A. 2 cabinets at 18 naira per unit equals to 36 naira. Z to D. 5 cabinets at 12 naira per unit equals to 60 naira. Total cost equals to 13 naira plus 11 naira plus 28 naira plus 48 naira plus 36 naira plus 60 naira equals to 196 naira. 2. Repeating step 4. Dispatch and reception. D bracket X plus R bracket A equals to 13 naira. 1. D bracket X plus R bracket B equals to 11 naira. 2. D bracket Y plus R bracket B equals to 14 naira. 3. D bracket Y plus R bracket C equals to 12 naira. 4. D bracket Z plus R bracket A equals to 18 naira. 5. D bracket Z plus R bracket D equals to 12 naira. 6. The result would be D bracket X equals to 0 naira, D bracket Y equals to 3 naira, D bracket Z equals to 5 naira, R bracket A equals to 13 naira, R bracket B equals to 11 naira, R bracket C equals to 9 naira, R bracket D equals to 7 naira. 3. Repeating step 5. Shadow cost of unoccupied cells. D bracket X plus R bracket C equals to 0 naira plus 9 naira equals to 9 naira. B bracket X plus R bracket D equals to 0 naira plus 7 naira equals to 7 naira. D bracket Y plus R bracket A equals to 3 naira plus 13 naira equals to 16 naira. D bracket Y plus R bracket D equals to 3 naira plus 7 naira equals to 10 naira. D bracket Z plus R bracket B equals to 5 naira plus 11 naira equals to 16 naira. D bracket Z plus R bracket C equals to 5 naira plus 9 naira equals to 14 naira. Summary. To solve a transportation problem, you first set up the problem in a standard transportation table and make the initial feasible allocation, northwest corner NWC rule, least cost method LCM, or the Vogel's approximation method VAM. You can then calculate the total cost of the allocation, the nominal dispatch and reception cost for each occupied cell, and shadow cost of the unoccupied cells. Check if the result is optimal, and if not, make maximum possible allocation into the cell where actual costs are less than shadow cost, and repeat all the earlier procedure till you attain optimality. End of study session 6. Thanks for listening.